Hey gang, and welcome back to another video and the final video of carbohydrates here on JoChem. Okay gang, I know this has been a long series with a lot of terminology, but last video, gonna keep it short, just stick with me. So, this video is all about disaccharides, and in my experience, I usually the questions you get with disaccharides in a college level undergraduate organic chemistry class is, identify a 1,4 beta or alpha glycosidic linkage, draw an example of a disaccharide. So I'm going to keep it pretty simple. So if we take a look right here, I have two disaccharide examples up here for us. So when you stick two monosaccharides together, the connection between them is called a glycosidic linkages, and that terminology is very deliberate, right? Very similar. It points at that our conversation about glycosides earlier in this series. So if you take a look at maltose, for example, right? These might be things you've actually heard of before and just in real life. So if you take a look right here, what you actually see is we do have D-glucose, and so this is 2 alpha D-glucopyranoses, right? So this is maltose specifically. So what you can see is that if you were to take the first, the one end, and the anomeric carbon, quote unquote, gets a position of 1. So if you look at this one and obviously that one, if you count away from this one over here, 2, 3, 4, you get an anomeric carbon with a position of 1, and then you get kind of the connection piece on the other monosaccharide within the disaccharide. So that's kind of what this 1,4 refers to. And based on how that linkage is put together, from kind of the one's perspective, then you can determine whether it's a alpha or beta linkage. So here this is going down, so that's why this is categorized as an alpha glycoside, or you could call this an alpha glycosidic linkage, right? And that's characteristic of maltose. If we take a look at cellobiose and apply the same type of numbering scheme, right, we can say, all right, this is going to be our position number 1, and then from this anomeric carbon over here, we can go 1, 2, 3, and then 4. So you can see it, the anomeric carbon to the left, right? It looks like this is going up, so that's why we would call this a 1,4 beta glycoside. And I'll be honest with you, gang, besides being able to discern that type of information, the only other thing I could possibly imagine that you could be asked for, and maybe I'm wrong, I've been wrong before, we'll be wrong again, is actually showing the creation of, smushing two monosaccharides together, but it's the same type of mechanistic pattern that you would just make a normal glycoside with. You protonate the anomeric carbon OH, swing down electrons, you form that double bond there, and then you would just instead bring a whole monosaccharide in like this to attack, and it would be this OH right here, which would be this oxygen right here, that would actually do the attacking. So I leave that up to you all as a challenge. Gang, thank you for rocking with me through carbohydrates. I hope it was helpful. If you're watching me from YouTube, so glad you found the channel. Make sure to check out the actual website for guided worksheets and solutions, 100% free. And if you're watching from JoChem, then you're a rock star. Okay, gang, I hope to see you all in the next series.